Hey guys, this is 1.6. This is the last unit this is the last lecture in unit 1. We're talking about absolute value equations, how to solve them, and how to solve absolute value inequalities. So this is the end of unit 1. You'll have your unit 1 test, and then we'll go into unit 2. So what does absolute value mean? Absolute value means that what is absolute value is finding out the distance between that number, whatever is inside here, and 0. Okay? It does not matter if you are moving, so you're on a number line. And the middle of the number line is 0, right? So if you move to the right of the number line, your numbers are getting bigger. Your values are greater, or your numbers are more likely to be positive, right? Or higher. As you move left on the number line, your numbers become negative or less, right? Less than, greater than. Is it lesser or less? Less than, right? Less than, greater than. So with absolute value, you're just talking about distance, and distance can never be negative. So it does not matter if you are moving on the number line in a positive direction or a negative direction. It is just a measure of distance. So this is the number 3, right? On the number line. 3, the distance between 0 and 3 is 3. Here's negative 3. The distance between negative 3 and 0 is also a 3. So absolute value will always be greater than or equal to 0. All right, it will never be a negative number. So if I have, let's see. Let me see. If I have the absolute value of x is 5, what can x be? X can be 5, and there is one other number that x can be. X can be negative 5. Okay? And we had a question about this in class. How can x be negative 5 if there's an absolute value here? But we're putting the negative 5 in for the x. So that's the same as saying what can be here, right? This can be here in place of x. It is true. This can be here in place of x. It is true because negative 5 to 0 on the number line is an absolute value of 5. Okay? But what can never be true, so this is the difference, right, between the two possible answers and what can never be true with absolute value. This one is a no solution. This will never be true. Okay? So we're finding the value within the absolute value bar. So there are 2 possible answers. All right. The absolute value of u is a. Sorry, the absolute value of a is u, and the absolute value of negative a is u. So we work backwards to solve for u, right? And the absolute value will either be positive or negative of the u. Here are the steps to solve the absolute value equation. First, isolate the absolute value. That means you want this alone equal to something. Okay. This is isolated. This is not isolated because you have the 2 on the same side as the equal sign. That is not isolated. This is isolated. Not alone, okay? Then you're going to rewrite, you're going to take away the absolute value bars, write it as equal to A or equal to negative A with no absolute value bars. And then you're just going to solve it like any other equation, okay? So this is already isolated, like we said, so we're going to rewrite as 2 equations. X plus 4 equals 13. Or that same x plus 4, and then the opposite of 13, which is negative 13, all right? Now, all we're going to do is solve for x. So in this case, that means subtract 4. X is 9. 9 plus 4 is 13. The absolute value of 13 is 13, so that's okay. All right, here, same thing. Solve for x. X is negative 17. Negative 17 plus 4 is a negative 13. The absolute value of negative 13 is 13, so that one's okay as well. All right, this one's not isolated, so we need to take the first step before we rewrite it. The first step would be get rid of the 2. It's a positive 2, so I'm going to do the opposite. So now I still have the absolute value of 2x minus 3 here. And then I have 7 minus 2 is 5. Now it's isolated. Now we can rewrite as 2 equations representing it being equal to 5 or being equal to negative 5, okay? Here it is. We would say 2x plus, I did that in class too, 2x minus 3 is 5, or 2x minus 3 is negative 5. Now solve for x. Add 3. Add 3. 2x is 8. We don't need to do it that way. Do one at a time. All right. Divide by 2. Divide by 2. X is 4. Shall I check that answer? So that just means I'm going to put everything in here. What did I say my answer was? 4. All right. So 2 times 4 minus 3 is 5. The absolute value of 5 is 5. 5 plus 2 is 7. So that answer is okay. Now let's do the other side. Add 3. Add 3. 2x is negative 2. Divide by 2. Divide by 2. X is negative 1. 2 times negative 1 minus 3 is negative 5. The absolute value of negative 5 is 5, plus 2 is 7. So that answer is okay. All right, and so that is how you solve absolute value equations. Now we have inequalities. With inequalities, let's just start with an example. All right, our example is the absolute value of x is less than 3, okay? Think of every value I could substitute for x, take its absolute value and get a number smaller than 3. Think about where that would be on the number line. Here's 0. There's 5, 3, 1. 5, 3, 1. Here's my number line. Where on the number line will the absolute value of x be less than 3? Well, I know less than and not equal to is just the parenthesis, right? And it goes to 0. Yeah, 0 is less than 3. The absolute value of 0 is less than 3. What about the absolute value of -1? Is that less than 3? Yeah, we can keep going. We can go all the way up. Sorry, these were supposed to be negatives. We can go all the way up to -3, right? So -2.9, the absolute value is less than 3. Yes, because the absolute value of -2.9 is just 2.9 is less than 3. So less than the absolute value, you take that number and then you take its opposite and you put the x, you put all the values between its opposite and itself. So the way I would write it is x is less than 3, right? Exactly what we have. And x is greater than the opposite. The opposite of 3 is -3. Which would look like this in interval notation. Does that make sense? Everything smaller than 3, and then everything between 0 and -3 are smaller than 3 if we take the absolute value of them. All the values between that number and its opposite will fulfill your equation. So the rule is, and I wrote it here because I would put it on my note card. The rule for less than for an absolute value is, if the absolute value is less than a, then we rewrite it as -a is less than it, no absolute value bars, which is less than the original a. Okay, so here, same rules as before. Isolate the absolute value, set it equal to its new equation, or sorry, inequality, and then isolate x. Okay, so the absolute value of x is less than 4. The absolute value is isolated, so we rewrite it. No absolute value bars, keep that the same. X is less than 4, and x is greater than the opposite of 4. You're done. Now you can graph it. You can graph it if you want. Here's -4. Here's +4. X is between those. Just like that. You can write it as interval notation, parenthesis, -4. It starts at -4 but does not include it. Goes to 4 and does not include it. All right, same thing. Set it, rewrite it as this because it's already isolated. So we've got 3, 2x plus 4 is less than or equal to 3. And greater than or equal to -3. Ooh, I forgot about that. Okay, so it could be this. It could just as easily, it does not change anything if it also has the equal to. Exact same rule, okay? Yikes, I forgot to say that in class today. Sorry, guys. So same rule, whether or not it has the equal sign. All right. What's the first thing you would do to now isolate x in the middle? We say in the middle because we created a middle. with this part of the inequality. Subtract 4. -3 minus 4 is -7. This is 2x, and this is -1. One more step. I'm going to divide by 2. Anything I do to the middle, I have to do to either side, so I did it 3 times. These don't really reduce. I'm just going to say x is less than or equal to a -1/2, and x is greater than or equal to a negative, a positive. No, sorry, it's a subtraction. I thought I was dividing. -7/2. Okay. And you're done, because you can't make that any simpler, or that one. Now we just graph it. Here's our line. Which one is bigger? Which one would be on this side? -1/2 is here because -7/2 is actually 3.5, right? Three and a half. All right, so x is between them, right? X is bigger than this one. X is smaller than this one. But these get brackets because of the equal sign. So that's how I would graph it. And then based on that, interval notation would have a bracket. Tell me where it starts. It starts at -7/2 and includes it, and it ends at -1/2 and includes it. Okay. Third one. The absolute value of 1 minus 4x is less than 5. It is already isolated, so I'm just going to say -5 is less than 1 minus 4x, which is less than 5. So no absolute value bars because I wrote the -a, the u, and the a. So no absolute value bars. Now I'm going to solve. I'm going to subtract 1 everywhere. -5 minus 1 is -6. That cancels. -4x. And this is 4. Now I need to divide. I'm going to divide by a -4. Because I'm dividing by a negative, remember, we flip the sign. Do you remember why? 2 is greater than 1. True? What if I multiply them both by a -10? Now I have -20 is greater than -10. Is that true? No. It is only true if I flip the sign. So anytime you're multiplying or dividing by a negative, we need to flip the sign to keep the inequality true. So I'm dividing by a -4, so I need to flip the inequalities. -6 divided by -4 is a 3/2. -4 divided by -4 is just an x or a 1x. 4 divided by -4 is a -1. I flipped these. So that's a little bit confusing because -1, if I was to put it on a number line, which is my next step, -1's over here, and 3/2 is over here. Ugh. I would rewrite it. You don't have to. If it doesn't confuse you, you don't have to. So -1 is smaller than x, and x is smaller than 3/2. Or 3/2 is greater than x, and x is greater than -1. It is important in interval notation that you do start with -1. If you wrote, so you can write this is okay. But if you wrote that you start at 3/2 and you go to -1, that's not the direction of the number line. So that you cannot say. So this is the less than, right? If the absolute value is less than the number. Here is greater than. Greater than. Okay, so if the absolute value is greater than a, then we write that same equation, inequality, absolute value is greater than a, or we flip the sign and we should call this a symbol. We flip the symbol and add a negative sign or change the sign. Flip the symbol, change the sign, okay? Instead of a greater than, it's a less than. And instead of a positive, it's a negative. So same thing, let's talk about x. Now let's talk about absolute value of x is greater than 3, okay? Every value I could substitute for x, take the absolute value of it and get a number bigger than 3. Here's 0 again. I'm gonna count by 2s because that other one was confusing. -2, -4, -6. All right. Which of these is greater than 3? Obviously, everything over here, right? But also, if it is greater than, or if it's a bigger negative, which is smaller, if it's a bigger negative than -3, it will also be true, right? So I can also say right here that everything smaller than -3 will fit here. -6, the absolute value is 6. 6 is bigger than 3, right? Everything bigger than 3, everything smaller than -3. So if the absolute value is greater than a number, it is going to be all the numbers greater than that number to the right of that number on the number line, or less than the opposite of that number to the left of that number on the number line. Okay, and what it will look like is x is less than 3, or x is greater than -3. Here's the one part that's a bit more difficult when you're writing interval notation. So it starts at -infinity and it goes to -3, right? This one. And this one starts at +3 and goes to infinity. And we have to say set here. The set of -infinity to -3 and 3 to infinity. Set. Okay? So first, isolate. Oh, they're all isolated. Then set them equal to this equation, this inequality. Okay? So the absolute value of 7x is greater than 42 means (7x) is less than -42, or 7x is greater than 42. Exactly what I already had. Or we flip the symbol change the sign. Right? Now I just need to solve for x. Divide by 7, divide by 7. X is less than -6. Divide by 7, divide by 7. X is greater than 6. I like to do the less than over here and the greater than over here because it's just a little bit easier to graph usually. So you have -6, +6. X is less than -6. That means it's all the numbers smaller than -6. X is greater than 6, all the numbers bigger than 6. Going forever. So that will look like -infinity to -6. 6 to infinity. The union of -infinity to -6 and 6 to infinity. All right, next one. Already isolated. Now we're going to set them each, okay? (2x minus 5 is less than -3, or 2x, that same 2x minus 5 is greater than 3. That exact same equation without the bars. Now I just solve for x. Add 5, add 5. 2x is less than 2. Divide by 2. Divide by 2. X is less than 1, right? Same thing over here. Add 5, add 5. 2x is greater than 8. Divide by 2, divide by 2. X is greater than 8 divided by 2 is 4. So I need a 1 and a 4. X is less than 1. X is greater than 4. From -infinity to 1, the union with 4 to infinity. So are you seeing how with less than, our graphs look like this. With greater than, our graphs look like this. All right. Last one is the absolute value of 3x plus 4 is greater than or equal to 2. So that's already isolated. I just need to write it twice. 3x plus 4 is less than or equal to the negative or the opposite of 2, or this very equation without the bars. 3x plus 4 greater than or equal to 2. Now I solve for x. Subtract 4, subtract 4. 3x less than or equal to -6. Divide by 3, divide by 3. X is less than or equal to -2. subtract 4, subtract 4, 3x greater than or equal to -2. Same division by 3, but we're just going to leave it as x is greater than or equal to -2/3. Okay, how will I graph this? Which one's bigger? -2/3 is less than 1, right? Less than -1, and -2. 2 is bigger than 2/3, right? So -2 is smaller than -2/3. It's a bracket, it includes -2, and it goes forever less than -2. It includes -2/3 and goes forever in a positive direction. So from -infinity to -2, the union with -2/3 and infinity. So on my math lab, they will ask you, okay. On my math lab, they will ask you if the solution is finite or infinite, if there are infinite solutions or finite solutions. Finite means you can make a list, 1, 2, 3, 4, 5. Infinite means you're going to use less than or greater than. So if you're trying to decide where to put, like they ask you to please put it in interval notation, and you don't know where to put it in interval notation is infinite. Because you can just get smaller and smaller and smaller decimals that are part of this, right? And you need to put the U, the union sign, between the two groups. Okay. The other one, this one, you don't need any U because it's only one bracket. But when there are two brackets, you need to unite them. Okay. All right, real quickly, let's just do 2 examples from my math lab because I think they're difficult and so it might be helpful. Number 11 says the absolute value of 1 minus 6x minus 1, sorry, minus 11 is less than -2. I made that confusing enough. All right, so the absolute value of 1 minus 6x minus 11 is less than -2. What could x be? All right. So first, this is not isolated. So you want to isolate it. Okay. We isolate it by getting rid of everything except this on this side. Add 11. I'm going to put it right under the -2 because they are like terms. So this is the same as 11 minus 2, which is 9. And this is the absolute value of 1 minus 6x. Okay. So now I can set them as equals, okay? So now I have, it's less than, so now I have -9 is less than 1 minus 6x, which is less than 9, okay? I want to solve in the middle. So in the middle, I want x alone. So I'm going to subtract 1 everywhere. 9 minus 1 is -10. This is a -6x, and this is an 8. Okay. Now I need to divide by -6. -10 divided by -6, you can divide both of those by 2, so that becomes, new color, that becomes 5/3, right? And it's positive because a negative divided by a negative is a positive, is less than, oops, 6 divided by 6 is just x. And then 8 divided by 6 becomes -4/3. But do you see what I forgot? I forgot to flip the sign. I think that's why I picked this one. So you need to flip the sign. I divided by a negative, so I need to flip the sign. Good. The graph would be, and remember this graph is flipped, so I need to put the -4/3 over here, and I would put the 5/3 over here. And then I would say it's everything between those two. So this would be parenthesis -4/3, and this would be 5/3. Okay, so that's number 11. And number 15, let's do number 15. The absolute value of 7x minus 45 over 3 is greater than 6. Out of focus. Oh, the camera's tired. You did it. All right. So I chose this one because it has a fraction, right? So we need to clear the fractions. But it is isolated. So I can say is greater than. So I can say 7x minus 45 over 3 is less than -6. Or 7x minus 45 over 3 is greater than 6. And I want to get rid of the fraction, so I'm going to multiply by the least common denominator. The least common denominator is 3. I'm going to multiply everything by 3. That cancels that. I have 7x minus 45 is less than -18. Add 45, add 45. 7x is less than 45 minus 18 is 27. Divide that by 7. X is less than 27 over 7, right? You can't really simplify it. Here, the 3's cancel. 7x minus 45 is greater than 18. Add 45, add 45. 7x 63. 63 divided by 7 is 9, right? Almost wrote 9. Let's make sure. Yes. All right, so x is greater than 9. Here's my graph. I've got a 27 over 7, which is like a 3.5, 3.5, almost 4. And I've got a 9. X is greater than 9. And x is less than 27 over 7. So it goes from negative infinity to 27 over 7. The union with 9 and infinity. All right. Those were just 2 examples because, oops, because they were hard for me. So maybe you'd appreciate them. Thank you guys and see you next time.